Hi, I'm Dave Faganell of McMaster Faganell Homes. We're here in one of the houses we're just about to finish, and I want to talk a little bit about what makes a McMaster Faganell home what we call a high-performance home. And it has to do with how the home performs in the areas of energy efficiency, comfort, durability, quietness, the healthiness of the house. And what happened was 20 years ago, over 20 years ago, back in 1991, I was looking for a way to make our homes more consistent and have all the homes basically meet certain standards. So we hired the University of Minnesota Cold Climate Housing Center, who at the time was the leading building science efficiency expert in the country. And they taught us some very important lessons on how to build a house as a systems approach, that the whole house had to be thought out together. I'd like to introduce Tony Botkin. Tony's with Intelligent Energy Solutions. We're actually his first customer, and he's our energy efficiency expert. He does is involved in the design of the homes. He's involved in the installation, sealing, and he also does all the testing for our houses. Tony, why don't you talk a little bit about what you do, what services you provide for McMaster Faganell?
Sure. It all starts in the planning stage. We're looking at the blueprints ahead of time, doing calculations, for the energy efficiency of the house, the heating and cooling loads. So there's some real planning that goes into making this house a really comfortable, energy efficient home. During the construction, we're out here doing the insulation, the air sealing, which is the most crucial part of it all. We're using a lot of foam, a lot of caulk, sealing up all the cracks and crevices, spending a lot of time in the house during the construction stage, ensuring that the house has a very tight envelope throughout. We also look at the outside of the home, do some inspections, throughout, making sure everything is sealed. From the outside, the seams are taped, the house wrap's properly installed, flashings in place. All these things that make it a very durable house as well.
One of the other services you provide for us, so you do the calculations for the energy guarantee, because all of our houses, as I mentioned, have energy guarantees where we guarantee the energy efficiency of the home to our buyers for the first 2 years.
Yeah, absolutely. We'll calculate that up front, and then before the house is finished, or toward the end of it being finished, we come in and we do all of our testing. We'll come in, we'll do a blower door test to check the air tightness of the home, to see how leaky it is. And all these homes are coming in really tight. The national average is 3 air exchanges per hour, and you're coming in at better than half that, at 1.5 air exchanges per hour, on a very consistent basis. We're looking at the house with an infrared camera, making sure all the insulation is in place. There's nothing that was, missed, during the process or removed later. We're looking for air leaks with that as well. We're doing some duct tightness testing, to make sure the ductwork itself is where it should be. There's no excess leakage through there. We're looking at the furnace, hot water heater, to make sure they're functioning properly. So it's a real extra step of verifying, putting the house to the test before it's turned over to the client.
We're down here in the mechanical room of the house, and before I get into that, I want to talk a little bit about the house as a system, and one of the key elements is the sealing of the house. It's probably as key as anything, because to control temperature, to control energy efficiency, you've got to have a tight house. That was one of the first things we learned. So therefore, additionally, what we learned, and one of the improvements we made makes the McMaster Faganell house very unique, is the SYS panel. Right here I have a SYS panel, and a SYS panel basically provides a total thermal envelope of the house. Historically, builders have used OSB, they've used plywood to give the house a structural integrity. Well, the problem with that is it's got a lot of structural integrity, but it doesn't have any R value. So Dow Chemical, with that in mind, and being a leader in building science, they developed a SYS panel. The SYS panel has the R value to keep the house warm. It's basically wrapping the house with a blanket or several blankets, but it also has a structural integrity to keep the house from moving, settling, things like that, so that you have a house that's structurally sound. That's a big difference here. So then we get into a lot of techniques with taping, foaming, items like that that are really important. And Tony from IES, let's talk a little bit about some of the techniques your crews do, and also give people an idea of the relativeness of the tightness of the house, because it's all raw. It doesn't mean anything until you kind of put it into perspective for them.
Sure. We've been testing and insulating the homes since 2008. And as you mentioned before, your systems approach, there's a system of caulking and foaming and sealing and testing and verifying these homes that have produced some very good results on a very consistent basis. As a national average, the air exchange rate is 3 air exchanges per hour, and you are coming in consistently at 1.5.
So I understand this, everybody understands it. So you're saying the air in a house, on a typical house, will turn over 3 times an hour, so you've got that much leakage in a house?
Yes.
Okay.
Absolutely.
Now, is that an older house, a newer house, just an average new construction house?
That's the average for new construction,
Okay.
the code minimum anyway.
Okay.
Older homes, you'd see much higher, leakage rates on those. You'd see 4, 5, 6 times as much.
Okay. And then one of the significances that we learned about air leakage is when warm air hits cold air, you get moisture, and that's how you, maybe over the course of 20, 30 years, you get this mold and things like that with a leaky house. And one of the big things about these newer greenhouses is the durability aspect, not just the comfort and the energy efficiency and all the other things that go with it, but the durability. And that's one of the ways that we can keep the house from having too much leakage. The house will last longer, paint will tend to not peel as much. But anyway, so you've been finding some good results in our houses. Use the blower door test.
Yep, absolutely. Between the blower door test and the infrared camera inspections, where we come back and we look at all the walls, the ceilings, around the windows, so we're ensuring that every aspect of the home is sealed and insulated. We look at it during construction.
You talked about the superior results we're getting and how tight our houses are through the testing of the blower door and the infrared camera. People are also going to see that, and they have seen that for 20 years in their energy bills, because we do give an energy guarantee, and they're going to feel it in the comfort and so forth of the house. I think one of the biggest things about that really makes a difference is the cellulose insulation. We went to cellulose insulation about 10 years ago, and I mean it's got some real advantages. It's quiet. It's safer because it doesn't burn. It's tighter as far as airflow goes. But why don't you talk a little about that, because you guys really are an expert in cellulose insulation.
To start off with, it's a very green product as well. It's made 99% recycled content in it, so it's not only good for the house, it's good for the environment. There's no VOCs in it, so there's no indoor air quality issues with it, and all around it's just a great product. Installation, versus fiberglass, cellulose is blown into the wall, so it fills every crack and crevice and cavity in that wall. So there's no voids, no gaps. So you get a completely insulated wall, and with that completely insulated wall, it's also makes it restricts the air movement in there, so it's much more energy efficient that way.
Well, it's actually a large cost item, but it was one of the best things we ever did when we actually included it as standard in all of our houses. Another thing is, and I've been to classes with you in Wisconsin on energy efficiency and tightness. I think some of your techniques are really important. I mean, there's hard areas that we've learned that always tend to be problem areas. There's the rooms over garages. There's the master bathtubs where air gets underneath that tub deck from the outside, and the fireplace chases and the zero occurrence fireplaces. Those are all areas that the technique is really everything. Mm-hmm. Maybe you could just talk a little bit about what your crew does, your experience. It all plays a big role in it.
Sure. Yeah, those are problem areas or known problem areas for a lot of homes out there. And what we learned is that that area over the garage has to be completely sealed, completely dense packed, completely insulated. So there's some real time and effort that goes into making sure that's done correctly. That area under the tub that you mentioned, we got to put something solid back there. Treat that just as an exterior wall. Block that in, caulk it, seal it, completely insulate it, and it does really well. Same thing with the fireplaces. Get in there beforehand, pay some real attention to them, button them up, get them nice and tight, and it's a world of difference for the customers.
We've talked a lot about how we've made the house tight, how we've used upgraded insulation, how we've kept the total thermal envelope intact. Now we're down here in the heart of the house, the mechanicals. Yeah, but Tony, you're very adverse at what the features of these mechanicals. Why don't you talk about them a little bit?
Yeah, they're great systems, and before the systems are ever installed, during the planning stage of the home, there's some calculations taking place up front called a manual J calculation, where we're sizing, not only the units but the ductworks, and ensuring that there's some planning going into this instead of just throwing something in there hoping it works. Once the ductwork's installed and sealed up, it's taped and mastic throughout. We'll come in and test that with a duct blaster or duct tightness test to ensure that it's sealed as tight as it's supposed to be. The furnaces themselves are not only efficient, but they're also much safer. It's a sealed combustion unit. It brings in its own combustion air and power vents the exhaust to the outside. There's no chance of backdrafting, which you might find in an older system. The systems themselves are 95 plus efficient furnaces. And they also have an ECM motor, which you don't find everywhere. The ECM motor uses about a third less electricity than your standard motor does. So not only are you saving money on natural gas, you're saving a lot of money on electricity as well.
Tony, can I ask you a question about the variable speed? These are variable speed furnaces, and I guess my understanding of the variable speed is that it's got kind of a basic speed that just is designed to move air almost 90% of the time through the house, and that makes the house very comfortable. But it's also got a capacity on really cold days or hot days to move a lot of air when you need it on those really those extremes. Is that correct? Is that
Yeah, the variable speed motor matched with the two-stage furnace, can provide you the heat and airflow you need when you need it. On mild days, it provide a lower heat on a more constant basis, but also the capacity, to ramp up during really cold days or really hot days during the summer and provide the heating and cooling needs of the house.
What's also nice about that is when we didn't know what we were doing as much, people would oversize the mechanicals was the tendency, and it's really bad from the standpoint, very inefficient because they're on, off, very uncomfortable, and the life cycle of the equipment is a lot less because it's on and off all the time versus just a slow, gentle moving of air and the ability to ramp up when you need it.
Absolutely. Hot water heaters. Everything here is a sealed combustion, so it's power vented to the outside, so it's a very safe unit. Once you seal these houses up really tight, you do have the potential of backdrafting an older atmospherically vented hot water heater. With these, there's no chance of that.
Backdrafting meaning that you're getting poisons pulled into the house?
Exactly. You're having, there's an opportunity to where you could pull combustion gas back down the flue and introduce carbon monoxide into the home, which you really don't want to do.
I know you've done a lot of, a fair amount of government work, these energy programs, these subsidies, and that's always seems to me is one of the big things they're asking for is you to test the house and make sure that that safety is almost the number one thing they're looking for, correct?
Oh, absolutely, yeah. Anything that has something other than a power vented hot water heater, we would test, to ensure that it's a safe house.
Okay. And around the back here, we have a Honeywell humidifier, and the Honeywell humidifier is actually the new generation where it's got a sensor. It doesn't just continuously run water through the system. It actually, when the air is saturated with the right amount of humidity, it basically turns itself off, and it saves about 5,000 gallons a year in water, which is another efficient item. We've talked about mechanicals, we've talked about the house being tight and how important that house is tight, and this is, I think, really one of the key components. This is one of the things we learned 20 years ago, it's actually almost approaching 25 years now, 23 years, when the University of Minnesota Cold Climate Housing Center came out here and says to make the house tight. But if you didn't know what you're doing, it could almost be worse than if the house was leaky, because at least when it's leaky, the air is exchanged and you don't have any issues. But when you make the house really tight, if you don't know what you're doing, you run the risk of poor indoor air quality and moisture problems. So what we've done, when everybody's touting energy efficiency, and new homes certainly are more energy efficient, but if you're really serious, you really know what you're doing, this is the best system on the market, using an energy recovery ventilator. This is basically a fresh air machine. It's constantly bringing fresh air into the house, yet it's not like opening your window, because we spent all this time and effort and money to make the house more efficient. We just want to open the windows. What this does is it has a core inside there. By ambient means, it takes the outgoing stale air. And outgoing air is much less healthier than the incoming air from the outside. It takes that incoming air, and through the core, it warms the cooler air, or heats it, or cools it in the summer, and basically you save that energy efficiency you fought so hard to get. Tony, anything you can add about this?
Yeah, there's a couple different ways, of introducing fresh air into the homes. As the homes get tighter, you do have to do that. But this is, without a doubt, the most efficient way of doing it, and the healthiest way of doing it. Because not only are you bringing in, fresh air, controlling some of the energy transfer between the two, it also puts it through a HEPA filter before it introduces it into the house. So you're catching 99% of the contaminants from the outdoors prior to that.
Tony, one of the big things we have your company do is test our houses, and we've been doing this Since 91, 92, before we even hired you guys, we brought a blower door, infrared camera, and we've always tested houses because we want to get a consistency. We want to really use building science to develop a consistent product. Why don't you talk a little bit about what you do for us in the way of testing and what the advantages are?
All the testing we do is just to verify, that everything's done as it said it would be. In addition to the blower door and the infrared camera, we're also testing ductwork these days, making sure that it's substantially tight and there's no leakage, getting the airflow to the rooms where it's intended to. We're also looking at airflow in the individual rooms. We'll come around, we'll measure airflow from each one of the registers and do individual testing that way. Testing the bath fans, to make sure there's no kinks in the lines, there's not obstruction in there, that you're getting the full amount of flow from those fans, and eliminates moisture problems and other issues in the bathroom.
To learn more about McMaster Fagenal High Performance Custom Homes, please call them at 630-916-4722 or visit their website at mcmasterfagenalhomes.com.